In this part, we will introduce some laws to allow you to solve for missing sides and angles of non-right triangle. We want to solve for missing sides or missing angles and missing angles of non-right triangle. Okay, so that means there is no right angle in this triangle, which is called oblique triangle. So the first one is called the law of sine. Okay, so this is the law of sine. If we have a triangle, there is no right triangle, okay? And if we denote this angle by angle A, and this is by angle B, and this is the angle C, okay? And the opposite side to the angle A, which is denoted by lowercase a, this is side A. The opposite side to the angle B is denoted by lowercase b, and the opposite side of the angle to the angle C, which is denoted by lowercase c. Okay, so the law of sine tells you that sine of angle A over A is equal to sine of angle B over B is equal to sine of angle C over C. So that means the ratio between the sine of the angle and the side opposite to it is going to be the constant throughout this triangle. So this is the ratio. It means the ratio between the sine of the angle and the side opposite to it, the opposite side, is going to be constant throughout this triangle. And here, the lowercase abc, we use the lowercase abc to denote the side, and the uppercase letter abc to denote the angle. Okay, so in order to do that, there is a efficient way. In order to solve an oblique, so that means we need to find the missing sides and the missing angle of an oblique triangle. We need to know three things, right? Out of the three angles and the three sides. If we can know three things, then we can solve an oblique triangle. We need to know three things. Okay, so for example, the first one, if we know two angles and one side, okay, and we denote AS. So here A represent angle. So we know two angles and one side. So this side, I write AAS means this side is not between two angles. Okay, for example, if you know angle A and angle B, AAS means you need to know the side A or the side B, not the side C, because side C is between angle A and angle B, right? So AAS, so we need to know two angles and one side. Then we can solve the oblique triangle, and this side is not between two angles. 2. ASA. If we still know two angles and one side, but this side is between these two angles, then we can also solve this oblique triangle. Okay, so this is the case for two angles and one side. And the third case is two sides and one angle. Okay, this is the SSA. We know two sides and an angle, and this angle is not between these two sides. So in other words, if you know C and A, okay, the side C and the side A, then we need to know the angle. This angle is not B. It could be A or C, but not B, because B is between it. So we write it as SSA. A is not between. And of course, if we know two sides, but the angle is between these two sides, we call it FAS. And the fifth one, we don't know any angle. So in other words, we know three sides. We can also find all the angles. Okay, and here in the first three cases, okay, the first three cases we can use law of sines. The reason is if you look at the first three cases, later you will see the examples. The first three cases that represent one angle and its opposite side. So we can always use this law of sine to solve the other things, right? Okay, so now let's look at these three cases, okay? And there is an efficient way to to solve the triangle, which is we need to draw a little chart. Efficient way to solve an oblique triangle we need to draw a little chart. Then fill in the blank, okay? So little chart means the first column represents the side, so we use A, B, and C, okay? We need to fill in the blank. And we draw the second column, which is the angle A, angle B, and angle C, okay? And we fill in the blank. Then we will see which law you will use, okay? So for the law of sine, if we know one side and its opposite, for example, this A and angle A, side A and angle A. If we know side A and angle A, and then we know another one, okay? You just choose arbitrary for the rest four items. If we know these three things, then we can use the sine, law of sine. The reason is we have a pair of the angle and its opposite side, okay? So here is some comments. Remark for this chart. If you have an opposite side and angle, then we can use law of sine. Okay, so now let's look at some examples. So the first example, which is the case 1, which is the angle AAS. Okay, so this is the first example, which is the case AAS. So we know two angles on one side, and this side is not between these two angles. So now let's look at this one. We have a triangle, and this is angle A, angle B, and angle C. And we know that angle C is equal to 102 degrees. And angle B is 29 degrees. And we know this is side B, right? This is side A, and this is side C. We know the side B is equal to 28 units. Okay, so this is the AAS, right? We know two angles and one side which is not between this angle A and angle C and angle B, right? Okay, so now we can draw a chart, a little chart, right? This is A equals something we need to know. We don't know yet. B is equal to what? Equal to 28. This we know, so we just fill in. And C is equal to what? We don't know. And angle A, okay, so far we don't know. Angle B, which is what? 29 degrees, right? Angle C, we know, which is 102 degrees. So you can see that if we look at this chart, we actually have one pair of the opposite side and the angle, right? We have this one and this one. So we can use the law of sine to solve this triangle. Okay, so the first thing is, since we know angle C, so we can always solve for C, right? So the side C. So we can use this this law of sine. So angle B, sine B over B is equal to sine C over C, lowercase c, right? Okay, so now we know that C is equal to sine C times B, right, over sine B, right, if you solve for C. Then we plug in the numbers, okay? So we know this B is 28, so we put 28 here. And this sine of C is 102 degrees. So one thing is you cannot multiply 102 by 28. The reason is this 28 is a number which is outside this function, right? Sine like a door. You cannot open the door and enter it, right? Over sine B. Sine B is 29 degrees. Okay, then we can use your calculator, right, to calculate this side C. So side C is, if we keep the two decimals, 43.59 units. Okay, so we fill in 43. So sine C is 43.59, okay, to get the side C. So now we want to know side A and side angle A, right? But for angle A, there is a quick way we can get, because if we know two angles in a triangle, we can always get the third angle, right? The reason is the sum of these three angles in a triangle should be equal to 180 degrees, right? So angle A is actually equal to 180 degrees minus 29 degrees minus 102 degrees, right? Which is equal to 49 degrees. So this is angle A is 49 degrees. Okay, so now we know angle A, so we can use the law of sine to get angle at the side A. So here is one suggestion. We'd better to use the pair that the problem gives you, not the pair you just calculate. The reason is, if you use the side C and the angle C, it will cause some approximation error. The reason is this side C is approximation number, right? We just keep the two decimals, right? So it may cause some error if you use this side C and the angle C to get to this side A. So you will have some calculation error, right? So we still use side B and angle B. So this is the sine. So we have sine A over A is equal to sine B over B. So what is A equal to? A is equal to B times sine A over sine B, right? Then we plug in everything. So this is B times sine A. A is equal to what? A is equal to, we just calculate, which is equal to 49 degree. So this is 49 degree. B is equal to, we know it's 28, right? Over sine B, sine B is 29 degree. 29 degree. Okay. So if you use a calculator, it would be 43.59 unit. Oh, sorry, this is 43.9 units again. Yeah, this is maybe I made a mistake here. Side A. Yeah, anyway, so we can calculate this one. Here I made a mistake. So here, if you calculate this one should be equal to 56.49. Okay, so here is 56. .49, and this side A is 43.59. 43.59. Okay, then we know everything, right? So this is called solving a triangle. So this is the case for AAS, right? So no matter which case is, right, you just draw a triangle and label all the things, all the angles and all the sides, and draw a chart, right? Draw a chart, little chart, and fill in the thing we know. Then you can decide which law you will use. We actually will introduce two laws, right? One is called sine, law of sine. The other one is called law of cosine. So if we know the opposite side, we'd better to try the law of sine, because the law of sine is about the ratio of the opposite side and sine of the opposite angle, right? So this is the reason. Okay. So now let's look at another example. Another example, which is the ASA. If we know two angles and the side between these two angles. So for example, for this problem, if you have a triangle, and this is angle A, angle B, and angle C. And we know angle A is equal to 46 degree, and angle B is 20 degree. And this side B This is side C, and we know the side between angle A and angle B, which is side C. This is the 65 units. Okay, so now we can draw the little chart. This is side A, side B, and side C. And angle A, angle B, and angle C. Okay, and we fill in the conditions we already know. Side C equals 65, and angle A equals 46 degrees. Angle B is 20 degrees. Okay, but if you look at this chart, there's no opposite side and opposite angle, right? So some students may think, okay, we cannot use the law of sine. But actually, you can see that we actually already know angle C. The reason is the sum of these three angles A, B, C in a triangle should be equal to 180. So angle C we can get very quickly, which is 180 degrees minus 46 degrees minus 20 degrees, which is 114 degrees. So now we know the side C and the side and angle C, so we can use the law of cosine, a law of sine to solve the side A and the side B, right? So we can use sine C over side C is equal to sine B over side B, right? So this tells you that B is equal to what? Sine B times C, okay, side C over sine C, okay? And the side C we know, which is equal to 65 times sine B. Sine B equals what? Equals 20 degrees over sine C. C is equal to 46 degrees. So one thing you should be careful, when you use your calculator to calculate the sine values, make sure you need to choose the correct mode. There are two modes. One is called the degree mode, the other one is called the radian mode. So here, this problem, the angle is given by the degree, right? The unit degree. So we need to use the degree mode. And if the angle is given by the radian, then you need to use the radian mode, okay? So if you calculate, so if you calculate, I don't want to do the calculation. Okay, I can calculate this one for you a little. So it's the 65 times sine 20 degrees divided by sine 46 degrees, which is equal to, if we keep two decimals, this is the 30.91. Okay, so this is this is the 30.191. Okay, so here then we need to calculate the side A, right? But we will not use the side B and angle B to calculate the side A. The reason is the side B is already approximation number. So if you want to use this approximation number to find another approximation number, then your error will be increased, right? So we still use the side C and the side angle C to calculate the side A. So here is sine C over C is equal to sine A over A. Right, so this is side A is equal to, we calculate this one is C times sine A divided by sine C. So C, we know C is 65 times sine A is equal to 46, divided by sine C is 114. Okay, so here, sorry, I made a mistake. So here is, this one should be the 114, right, not 46, 114, so this is wrong. This one should be the 114. So it should be equal to 24.34. Okay, so this should be the 24.34. Okay, so here is, this is a 114 degrees, so let's do the calculation. So this is 65 times sine 46 degree divided by sine 114 degree. So this one is equal to 51.18. So here is 51.18. So you can see we actually solve all the things, right? All the missing sides and the missing angles. So this is the first two cases, right? So the next case is about SSA. So we know two sides and one angle, but this angle is not between these two sides. Okay, so this case is a very complicated case which is called ambiguous case. The reason is this case may have three situations. One is you will see sometimes there is no such triangle. This triangle does not exist. Okay. The two, there is only one triangle satisfy the conditions, two sides and one angle, and this angle is not between these two sides. And the third situation, which is there are two distinct triangles. Okay, let's see why this would happen.